Hello everybody, in this lesson we are on chapter 2, lesson 2.3, converting between fractions and decimals. By the end of this lesson you should be able to convert between different forms of rational numbers, explain the difference between terminating and repeating decimals, write fractions and mixed numbers, and then write decimals as fractions and mixed numbers. Okay? So, first things first, let's see what is what. So now we can divide an integer by a non-zero. You can also use long division to write fractions. Now, these are rational numbers and they will either terminate or repeat. Well, let's think about these words really quick. Terminate, terminator. What does that mean? To terminate. It means to end, to stop. It doesn't go on. Whereas the word repeat means it continues and it just repeats, okay? We've run into this and this should be fairly easy for us to solve. So, what is a terminating decimal? Well, let's take a look at this one. 1.5. It stops. There's nothing after 5. It's just 1.5. Okay, let's take a look at the other one. Negative 0.25. Again, it stops. There's nothing after that 0.5. 10.824. Again, it stops. There's nothing after that 10.824. Repeating decimals. What does that mean? That means it goes on forever. It doesn't stop. One way we can tell that it's a repeating decimal, it either continues on or we have this line right on top of it. That is a repeating decimal, right? 15, 15, 15. So you'd put a line over the 15. That would be a repeating decimal, okay? So how do we know it's a repeating decimal? Well, we use the bar notation. So for example, it'd be like 0.34. That's telling me that 0.34 continues to repeat. 0.34, 0.34, and so forth, okay? That bar is telling me that it repeats. So that is exactly how we can tell the difference between a terminating decimal and repeating decimal. Let's do a few examples. In example number 1, we are going to write negative 2 1/4 as a decimal. Well, how do we do that? Well, first we need to turn this negative 2 1/4 into an improper fraction. How do we do that? 4 times 2, so we multiply, which would give us negative 8, and then 8 plus 1 will give us 9/4, and that's negative, okay? So now that we have that, all we need to do to turn this into a decimal is to divide. So 9 divided by 4, right? That's a negative answer. So now let's see. How many times does 9 go into 4? It goes into there 2 times. 2 times 4 is 8. We subtract that. 9 minus 8 gives us 1. Now we add a decimal. Does 4 go into 1? No. We add a decimal, bring down that 0. Can 4 go into 10? Yes, it can. 2 times. 2 times 4 is 8. We subtract that. 10 minus 8 gives us 2. Can 4 go into 2? No. Add a 0. Bring that down. Can 4 go into 20? Yes, it can. It can go into there 2 times. So the answer for this problem, turn negative 2 1/4 into a decimal. That is negative 2.25. Okay? Let's try another one. Write 5/11 as a decimal. All we need to do is divide. 5 divided by 11. Can 11 go into 5? No, it can't, so we can add a 0. Can 11 go into 50? Yes, it can. 4 times. Don't forget to add your decimal. 4 times 11 is 44. We subtract that. 50 minus 44 is 6. Can 11 go into 6? No, we add a 0. Can 11 go into 60? Yes, it can. 5 times. 5 times 11 is 55. We subtract that. 60 minus 55 is 5. Isn't that interesting? That's where we started, right? 11 goes into 5. Well, let's finish it off. Can 11 go into 5? No, it can't. Let's add a 0. Can 11 go into 50? Yes, it can. 4 times. 4 times 11 is 44. We subtract that. We get 6. Can 11 go into 6? No, it can't. We add a 0. Can 11 go into 60? Yes, it can. 5 times. That's 55. And it's just going to keep on repeating. So well, it'll go on forever. It'll just never stop. So how do we know where to stop? Well, once you see the repeating, you can stop. So I already knew that it's going to stop right there. So my answer for this problem will be 45 repeated. Okay, this is a repeating decimal, whereas this one is a terminated decimal. All right, let's do a few more practice problems. Let's divide. 6 divided by 5. Can 5 go into 6? Yes, it can. 1 time. 1 times 5 is 5. Subtract that. Get 1. Can 5 go into 1? No. Bring down to 0. Can 5 go into 10? Yes, it can. 2 times. Subtract that. We get 0. So the answer for this one is negative 1.2. Let's try another one. So first things first, we need to turn this into a improper fraction. 8 times 7 is 56. And then 56 plus 3 is 59 over 8. Now we just need to divide. So 59 divided by 8. Can 8 go into 59? Yes, it can. 7 times 8 is 56. Oops, 56. Subtract that, you get 3. Can 8 go into 3? No, it can't. Bring down a 0. Can 8 go into 30? Yes, it can. 3 times. 3 times 8 is 24. Subtract that, we get 6. Can 8 go into 6? No, it can't. Bring down the 0. 8 can go into 60 7 times. 7 times 8 is 56. Subtract that. What do you get? 4. Can 8 go into 4? No, it can't. Bring down the 0. Can 8 go into 40? Yes, it can. It can go into there 5 times. 8 times 5 is 40. And there we go. We have 0. So our answer for this question is negative 7.375. Okay. Let's do this last one. Again, ladies and gentlemen, how are we supposed to do these actual problems? Please stop before I answer the question. So I know that I'm answering the question, but your job is to do this problem on your own. So your job is to do this problem on your own before I even finish. So press pause on YouTube, write down the question, solve it, then watch what I did. All right? So the next one, 3 divided by 11. Can 11 go into 3? No, it can't. Add a 0. Can 11 go into 30? Yes, it can. 2 times. That's 22. Subtract that, you get 8. Can 11 go into 8? No, it can't. Add a 0. Can 11 go into 80? Yes, it can. 7 times. 7 times 11 is 77. And then we get 3 again. So I already figured out that it's going to repeat 30 and then 80. So my answer for this problem is just negative 27 repeated. All right, let's do the last one. Again, last step is to turn this into a mixed number. 27 times 1 is 27, plus 5 is 32. 32 over 27. So now let's just divide this. 32 divided by 27. Can 27 go into 32? Yes, it can. 1 time. 1 times 27 is 27. Subtract that. What do you get? You get 5. Can 27 go into 5? No, it can't. Add a decimal. Bring down the 0. Can 27 go into 50? Yes, it can. 1 time. That's 27. We subtract that. What do we get? 20. So let's see. 10 minus 7 is 3. And then 4 minus 2 is 2. Can 27 go into 23? No, it can't. Bring down a 0. So let's see. Can 27 go into 230? Well, I don't know. But I know 27 times 10 is 270. So I'm going to try 8 times. So let's see if that works. 8 times. 8 times 7 is 48. Sorry, not 48. It's 56, right? So it's 56. Oops. Carry the 5. 8 times 2 is 16 plus 5 is 21. So it's pretty close. So it's pretty good. Now 230 divided by 216, that will give us 14. Can 27 go into 14? No, it can't. Add a 0. Bring that down. Can 27 go into 140? Yeah, so I think 5 times 30 is 150. So 5 times 27 should be pretty close. So let's see, 5. 5 times 7 is 35. Carry the 3. 5 times 2 is 10 plus 3 is 13. There we go. And 140 minus, and it looks like it starts all over again. So right here is my 5 and it starts all over again. So the answer for this problem, I figured out that this is repeating. So it's 1.185 repeats. And that is my answer. Ladies and gentlemen, this was example. In example number 2, we will talk about how to turn a terminating decimal as a fraction. So how do we do that? Well, so we have the number negative 0.26. What I want to do is I want to look at the last place. What is the place value for that? That is in the hundreds place. So that would actually be 26 over 100, it is negative, ladies and gentlemen. So last things to remember in 7th grade, we always simplify. So we still have to simplify this problem. So what number goes into 26 and 100? Well, I'm just going to be easy. I'm going to divide by 2. 26 divided by 2 is 13. 100 divided by 2 is 50. And I think that's about it. Remember, it is a negative. So the answer for this problem is negative 13 over 50. All right, let's try a few more. What is the place value for that? Well, that is the tens place, right? So that's going to be 3 over 10. Is there anything else to simplify? Nope. That is it, ladies and gentlemen. That answer is just 3 over 10. Let's try another one. Remember, we want to look at the last place. What is the place value for that 5? That is in the thousands place with the TH. So that's 125 over 1,000. Well, can we simplify this? Yes, we can, ladies and gentlemen. What number can we do that by? I would say 25. How many times does 25 go into 125? I'll say 5 times. And then 1,000 divided by 25, what is that going to be? I think 40. Let's see. So if 25 times 4 gets me 100, so multiply that by 10, right? 4 times 10, 100. Yeah, so it'd be 40. All right, and now can I simplify 5? Yes, I can. Divide by 5. 5 divided by 5 is 1. 40 divided by 5 is 8. So the answer for this problem is 1 over 8. Ladies and gentlemen, problems like this involve you to know your multiplication tables. You don't know your multiplication tables, you're probably going to get it wrong. So I remember I specifically told you guys a lot last year that you need to know your what? Multiplication tables. So please make sure you know your multiplication tables. All right, let's try another one. Well, here we go. So we have to turn this into a fraction. Well, first of all, again, we look at the last place value. What place value is that in? That is in the tenths place. So that's actually going to be 31 over 10. Remember, it is negative. And let's turn this into a mixed number, actually. So let's see. How many times can 10 go into 31? Well, 3 times. 3 times 10 is 30. So 31 minus 30 will give you 1 over 10. And that, ladies and gentlemen, is how you simplify these problems. Last one. Again, what do? We look at the last place value. What place value is that in? That is in the hundreds. So all we need to do is do 1,025 divided by 100. And then you will get, well, let's see what number goes into there. Let's just divide by 25. So 100 divided by 25 is 4. And then 1,025 divided by 25 will get you 41. So how many times can, let's turn this into a mixed number. How many times can 4 go into 41? Well, 10 times. 10 times 4 is 40. So 41 minus 40 will get you 1 left over. So 10 and 1/4. It's also negative. So that's 10 and 1/4. That, ladies and gentlemen, is how you turn a terminating decimal into a